What is aluminum? Aluminum is the most abundant metallic element in the Earth's crust, and it is the most widely used non-ferrous metal because of its chemical activity. Its density is lower than that of other metals. It's about 1/3 denser than steel. It also has an oxide layer that forms on the surface when it is exposed to air. A few characteristics of aluminum are it's soft, it's non-magnetic, and it's ductile, and it is the 13th element on the periodic table.
What are the grade families of aluminum and their properties? Series 1. Aluminum refers to a material that contains 99% pure aluminum or more. It is excellent corrosion resistant and electrical and thermal conductivity, but it is considered one of the weaker variants of common aluminum grades. Series 2 Aluminum. Alloys are primarily alloyed with copper. This combination results in increased strength but reduced in corrosion resistance. They are commonly used in aerospace, military vehicles, and bridge building, where a high strength to weight ratio is required. Series 3 aluminum is alloyed with manganese, which makes it a go-between for Series 1 and 2. It has a moderate strength increase on Series 1 without impacting corrosion. Series 4 aluminum alloys are primarily formed with silicon, which lowers the melting point of aluminum without producing brittleness, making it the ideal grade for welding, casting, and as a common brazing metal.
Series 5 aluminum alloys are primarily alloyed with magnesium. The addition of magnesium provides these alloys with increased strength compared to Series 1 and imparts excellent corrosion resistance. It is often used in marine environments for boat hulls and ship structures. Series 6 aluminum is alloyed with magnesium and silicon. This results in a good aluminum alloy that is both formable and workable, and it possesses good strength and corrosion resistance, and is most popular aluminum grade in the UK for fabrication. Series 7 aluminum is alloyed with zinc, which boosts the strength of aluminum, making the Series 7 alloys one of the strongest materials. Many of these alloys also contain smaller amounts of manganese, copper, and chromium to enhance their properties. And Series 7 is normally found in aerospace for building applications such as aircraft wings and fuselages. Series 8 aluminum alloys contain a mixture of either tin, lithium, or iron. These alloyed elements allow for excellent strength and durability. Series 8 is commonly used as foil for pharmaceutical wrappers and regular foil for food wrappers.
As we look at this filler wire chart, we see common grades of base metal aluminum and aluminum filler wire. To find the proper filler metal needed, we must have to find the corresponding base metal and match those up. For example, we are going to use 5083 as our base metal. Cool, now that we found our corresponding base metal in the chart, we are going to make a line over and down till both lines intersect. Perfect. Now we can see the filament metal that is best suited for 5083 aluminum is 5556 or 5183 aluminum filler wire. What are at least 5 pros and cons of using aluminum over other metals? 1. Its lightweight. Aluminum is 1/3 the weight of steel. It makes it the most ideal for applications that lighter metal is needed, and this benefits industries like automotive and aviation when less weight is used to increase fuel efficiency. 2. Corrosion resistance. Aluminum forms a thin oxide layer when exposed to air, which protects it from rust and corrosion. This makes aluminum suitable for use in environments where resistance to elements like moisture. 3. Its abundance. Aluminum is the third most abundant element in Earth's crust, ensuring a steady supply for industries and diminishing the risks associated with supply chain distribution. Number 4, malleability and ductility. Aluminum can be easily molded, shaped, and extruded into various forms. This adaptability is why it's frequently used in industries that require complex shapes. 5. Good conductor of heat and electricity. Aluminum is an excellent conductor of heat, making it popular in cooking utensils and radiators. Additionally, its conductivity makes it an essential material for electric transmission lines. Cons. Number 1, cost. Even though aluminum is abundant, the process of refining bauxite into aluminum is energy intensive, often making aluminum more expensive than other metals like steel. 2. Strength. While aluminum is strong for its weight, it isn't as strong as some other metals like steel. As a result, in applications where high strength is critical, it may need to be alloyed or replaced by other materials. 3. Fatigue resistance. Under repeated loads, aluminum can suffer from fatigue faster than some other metals. This limitation might restrict its use in specific applications where endurance under critical stresses is essential. Number 4, corrosion. When aluminum is in contact with certain other metals in the presence of an electrolyte, it can rapidly corrode. This phenomenon is known as galvanic corrosion. Number 5, oxidization. While the oxide layer on aluminum provides protection, when this layer gets scratched or damaged, it can lead to pitting and localized corrosion. Explain cross-contamination and how facilities deal with this issue.
Cross-contamination can be caused by grinding or wire brushing materials that were used to clean other products, such as a wire brush to clean, then use the same brush to clean aluminum. Also, storing two different types of materials together, which can cause scratching or damaging to each other, will cause cross-contamination. During grinding, polishing, and or cutting, materials can cause cross-contamination as the small particles in the air can land on the metal or combined in the weld, causing contamination, such as steel dust in aluminum, as one of the most common situations. Most fab shops facilities will separate the material to different parts of the facility to avoid cross-contamination altogether. But a lot of small fab shops can't do that, as they do not have enough room. So what they will do is they will make completely enclosed booths with filters to process materials with very minimal to no contamination. Grinding, cutting, and cleaning aluminum are specific to aluminum, with a few things in mind, with aluminum being softer and more prone to corrosion through contamination. So most cutting wheels and flapper wheels for aluminum are commonly made with aluminum oxide to prevent contamination. Other issues with grinding aluminum is that grinding aluminum with any pores or orifices in a grinding wheel not designed to grind against aluminum. Aluminum corrosion happens commonly as electrolysis or galvanic corrosion. This is a form of corrosion that occurs when one or more dissimilar metals are connected together, like copper or steel. This corrosion can happen rapidly, increasing if there is a electrolyte solution, like water, salt water, air, or humidity. When all these things from the electrons form one metal flows to the other, the metal with the most electrons, known as anode, is going to corrode as the electrons travel to the point where with the least amount of electrons, known as cathode.
A few ways to harden aluminum. Some aluminum alloys are capable of being heat treated, but aluminum in general can't be heat treated. Basic heat treating of specific aluminum like 2000, 6000, 7000, and 8000 series can be heat treated through rapid cooling of the metal while extremely hot. Aluminum can also be hardened by anodizing the aluminum, which involves passing electrical current through the aluminum, which causes it to form an oxide layer, and this layer acts like a barrier against things like moisture and chemicals. And anodizing also creates a smoother finish on aluminum. You can also increase the alloy content, and this can increase the strength and durability of aluminum. The benefits of increasing the alloy content include improved wear resistance and better corrosion resistance. Protective coatings can also harden aluminum and provide additional protection against corrosion, chemical damage, and wear. Paints are the most common types of protective coating. They provide good protection against corrosion and provide a smooth finish. Why does aluminum take more amperage to weld than steel? It takes more amps to melt aluminum because of its oxide layer that melts at 3,700 degrees Fahrenheit, and this layer is much harder to get through than the aluminum itself. And as always, thank you for watching Willie Walt's Welding Factory. Catch you in the next one.